Record. It looks like we're recording now. I'm going to share my screen. Give a brief recap of what we did on Monday, and then we'll plow right through. All right. Can you guys see my screen with Rhino? Hopefully. Excuse me. Okay. So we have this surface. It's in Rhino. What I did is I need to bring this into Grasshopper, reference it. So I'm going to make a surface widget from the params tab. Set one surface. Grasshopper disappears. Lets me select this surface that's in Rhino. Now I have it referenced in a Grasshopper, so I can build off of it. And essentially what I'm going to do is I'm going to, excuse me, is divide it up into cells, and then we're going to populate each of those cells with a shade component, right? And that's your task to do based off of your sketches for today. Over the weekend is to try your best to do the same thing here, right? Build it divide your surface up into a bunch of cells, and then populate each cell with your shade component. So really quickly, I'm just going to turn on, this is assuming that I've already run the Rhino script to generate a set of ribs here. Okay. And so I'm just going to turn those on really quickly to make sure that once I divide this up, that it corresponds to the same number of divisions as I used for making the ribs, right? So it's really important that each of these cells, that we divide these things up according to how you divided your surface up for the rib system and for your laser cutting, right? So I think that's a super important point to make. So whatever parameters I used for the number of divisions in the U, the number of divisions in the V, I'm going to use also here in Grasshopper when I divide this up into individual cells, grid cells, quads. So I'm going to go ahead and go to the Surface tab. I'm going to find isotrim. Okay, this is going to allow me to select or create just a little subset or checker or quad from the surface. I'm going to make a list of those. I'm going to do it a bunch of times across the entire surface to make essentially a checkerboard. I'm going to go ahead and right-click on this S input where I input the surface. I'm going to say reparameterize. Just a good habit to get into. Meanwhile, what I need to do is I need to actually create a set of two-dimensional domains. I'm going to go to sets, math, go to domain, and I'm going to divide a domain, divide a two-dimensional domain. So two-dimensional domain means that I have a minimum max in the U and a minimum max in the V, right? A two-dimensional domain. And so I want to divide each direction up a certain number of times. And then we'll tell it to, we'll tell Grasshopper to then use those new domains. No, what? Stupid Windows, all right. Where was I? Yeah, anyway, I'll generate a list of domains, two-dimensional domains, and I'll plug those in then to create a bunch of subset domains, right? In other words, to create all of these cells as individual surfaces. All right, so I need to create a domain from 0 to 1, since I reparameterized my surface from 0 to 1. I need to make a two-dimensional domain, actually. Let's see here. Let's go to you don't see all the icons here, right? So if you click on the label, it brings up a list that sometimes it's easier to find some of these things rather than just sort of relying on what the icon looks like. So in this case, I'm going to say construct a two-dimensional domain from 4 numbers, from 2 simple domains. 4 numbers works. And by default, it's already set to 0 and 1 in the U direction and 0 and 1 in the V direction. If I wanted to change that, I could put a number over here, a number slider, and then plug it in, right? U 0 to 1, V 0 to 1. That sounds perfect to me. And then the number of divisions. All right, so I'm going to use a number slider for that. I'm going to go ahead and constrain that to integers. Again, this is the stuff that we were doing on Monday, so it shouldn't be too surprising for you now. And you have examples of this both on YouTube and I think the file, even an example file has been given to you. So I'm going to guess here, let's see, that I divided this probably 15 times. And I'm not sure about the other direction, but again, probably 15 and 15. Okay, that works. Yeah, great. All right, with that said, now I can just turn these dudes off. I don't really need them anymore. I'm just going to turn off the layer so I don't see them. They're not in the way. A couple things you're going to see me do throughout the time here is I'm going to pull out some of these sliders and sort of make a column over here on the far left with some of the critical parameters that I can go back and change as variables later. Okay, that's really important because next week you'll be sort of thinking about these variables and think about how you can change them based on performance. So I just want to go sort of pull that out sooner rather than later, some of these critical parameters, like, for instance, the size and density and spacing of these cells. That happens right here at this 15 and 15. That's how many times we're dividing, how many columns and how many rows we're dividing our surface into, right? It's really important. So here's all of those grid cells, 225, not a big surprise, it's square 15. Great, so now what I'm going to do is I'm going to go to, again, my surface tab analysis. I'm going to go ahead and use the deconstruct brep. This is kind of like the explode command. So I'm going to take each of these checkers and quads, and I'm going to go ahead and explode them so I can find each quad's face, each quad's 4 edges, and each quad's 4 vertices. Okay. Now I don't want to just have a list of like all 4 vertices. I want the first vertex and the second vertex and the third vertex and the fourth vertex in their own lists. So that's what I'm going to do next. I'm going to go to sets, and I'll pull out the first vertex from each of those lists of 4 vertices. Okay, so I'm going to say 0, and I'll pull out the first item from each of those lists in the data tree. I'm going to copy, I'm going to paste this 3 more times because I have 4 vertices to take care of. So here's the first set. The second set will have an index of 1. The third will have an index of 2. And the fourth will have an index of 3. Except it would help if I actually typed in 3 on my keyboard. Okay, let's zoom in and see what's actually going on here, right? I'm just going to zoom in on one of these cells for just a moment and try to get my annotate tools to pop up. Here we are. All right. So for instance, what I'm doing is for each cell, maybe I'm getting this point. And then for each cell, for this widget, I'm getting the second vertex. And then each point in this list is the third vertex for each cell. And then this one, of course, would be the fourth, right? That's really important because later on I could connect the dots between these things, right, in any number of ways. I think yesterday I showed you how to make a diagrid by just simply connecting alternating vertices to make an X. But then once you do that across the entire field of cells, you get basically a diagrid, a set of diamonds. So that's really important because I'm going to locate other points on this quad, this cell. And then I'm going to like try to make surfaces by connecting the dots in some way, right? Again, with making triangulated surfaces in my case, right? So I'm just going to go ahead and clear that out. I hope that's kind of clear, right? So, oh, clear. Let's turn that off. Now I can select things. There we go. All right. So, and once again, it hides my chat box. Let me just pull that up and see if I can, yeah, here we go. Okie dokie. All right. So with that said, in parallel with this, I'm going to take each of these cells and I'm going to evaluate them at a UV parameter. In other words, I'm going to take each one. I'm going to give this widget, give Grasshopper a latitude and a longitude coordinate, right? It's going to locate a point along that surface at that coordinate. Okay, so again, I'm going to go to surface and I'm going to say evaluate surface at a UV parameter. Where's that at? Evaluate surface. There we go. Right. So there's the surfaces that I'm going to do, right? I'm plugging in all 225 cells at the same time. And I need to give it a UV coordinate. Just like I have a one-dimensional number slider, one that just moves one direction, back and forth, right? I can use a multi-dimensional slider. where I can move in 2 different directions at once, right? To generate a UV coordinate. All right, now let's see what that's doing here. While I zoom out, it looks really messy, and that's because not only is it giving us points at those locations, but it's giving us the normals at each of those locations, the surface normals. It's giving us the parallel frame at each of those values, right? And that's giving us a U direction and a V direction. So it's giving us a lot of information here, depending on which parts of the or which pieces of information that we actually want. One thing I forgot to do was to reparameterize this. Right click, right input the surface, and say reparameterize. Right now that'll go across the entire surface. Now what you're seeing is a bunch of frames and things like that. I'm going to go ahead and turn the preview off because that's really messy. And now I'll just have just the points display, right? That's kind of what I'm really interested in anyway. Right. Now you can see I can move those all the way down to the start point 0, 0, all the way across to the other point and anywhere in between, right? Interesting. Now, do you guys know what normals, do you guys remember what normals and tangents are? You guys might remember these from geometry or trigonometry, maybe even a little bit of calculus and physics if you were looking at the slope of the ever-changing slope of parabolas and things like that, right? Thinking about how trajectories arc as they across the sky as they're shot to or whatever. So really quickly, let's just talk about this. Annotate. If you think about a curve, right? At each discrete location along a curve, there's a tangent, right? Okay. Measuring the slope of the curve at just that instance, and typically with these free-form curves, that constantly changes as you move throughout the curve, right? So each location along the curve has a different tangent than the one preceding it and the one afterwards, right? Okay, so that's kind of like if you just measure what's parallel to the curve at that point only, right? The slope, that's what you get. Now, if you go perpendicular to that, so let's say that's a 90-degree angle, that's the normal, okay? And again, that changes, the perpendicularity of the curve changes according to the tangent of the curve at that moment, right? Now we're talking about curves, or I'm talking about curves at the moment, but we're talking about surfaces. So what's interesting is that if you think about a surface, let's draw like a part of a hemisphere here. That's pretty lame drawing of a half of a globe, but I think you get the general sense, right? Okay. At any point on this surface, you have not just one tangent, but 2 tangents, right? In other words, you have a latitude or a U tangent, and you have a longitude, sorry, latitude and longitude. So a longitude like a U and the latitude like a V, right? And so if you think about a frame or a plane that follows that, that's the tangent plane or frame, which is what this output is. If you think about what's perpendicular to that plane, shooting outwards, right? Almost like a spike shooting out perpendicular to the surface, right? That's the normal, okay? And then of course we can place a point at that location as well. That's what that does. So here's why we see points. All right, so we're gonna use that normal direction. That's gonna be really important for us here. I'm gonna go ahead and clear. There we are. Okay, so what I'm gonna do is I'm gonna draw a line at each of these points, at each of those normals, to sort of project outwards perpendicular, right? And it's gonna look like a big spiky chew toy for a dog or something. Or like it's growing hair, kind of gross, right? Anywho, so let's do that. Clear all drawings. Yeah, close those tools and I can get to work here. All right, so lines are curves. I'm gonna go to the curve tab. All the curve tools are here, including how to make certain primitive curves like lines. There's a lot of different ways to make lines. This one by start point, direction, and length seems pretty appropriate because I have my start point and I have my direction. These will be these normals, right? Now I just need to give it a length. Okay, which will be another variable. I'm gonna go ahead and double click on this number slider that I'm using. I'm gonna change the minimum to something ridiculously large like -10, and the maximum to something equally large in the opposite direction, like positive 10, and hit OK. Now I can adjust these in either direction, depending on what's up and what's down, right? In this case, I'm just going to go in the negatives. But this is another critical parameter for the shape and size, and therefore how my for each shade component, and therefore how it's going to perform later on when it comes to casting shadows and protecting things from the shade. So I'm going to go ahead and pull that over here, right? And instead of length, I'm going to call it height, right? This is sort of the height of my sort of half pyramids that I'm going to be making for my shade structure. All right. I'm going to go ahead and turn some of the previews off, just so you can see what we're talking about here, right? This is what we're dealing with, right? We have these set of curve points, these set of points, these vertices, these vertices. Now we have these points located somewhere along the surface, right? And from each one, we're drawing the normal, right, out from the surface. Now, I also want, oh, and that's adjusted by this parameter right here, yeah. Okay, so I also want to find, let's say, where my, it'd be really nice if these annotate tools would actually pop up when I need them to. I want to find the tops of each of these lines, right? Those are the endpoints, right? We had a point down here on the surface. We drew a start point, so we gave that as a start point, then we gave it a direction and a length to draw a line in this direction. But we want this endpoint, right? This apex, so to say, the peak, right? For what we're going to be creating. In this case, I'm making a really sort of lousy half of a pyramid or something like that. And so I'm going to take this line, and I'm going to go to curve, and I'm going to go to analysis and find the start and end points for each of these lines. And that way I have a list of endpoints. I think that's really important. Right, all right, there we are. Okie dokie, I can turn the preview off for that. Okay, and so now I have these endpoints, and I have these vertices, sorry. These vertices, these vertices, these vertices. Now I'm gonna start to connect things up in various ways, right? Okay, let's see here. Now, what do you notice here? Look at what's coming out. 0, semicolon 0, semicolon 0 inside of brackets, and then inside of parentheses after that, n equals 1, right? Okay, and so in other words, we go from 0 all the way to 224. We have 225 tree branches in our tree, right? Those correspond to the 225 quads that we exploded, right? And then each side of each of those branches, we have a list of one item, right? So that's the first vertex point from each of those quads, right? Each of those cells that we exploded, right? Each of these things. But they're data trees. And then we have this. We want to match them up with this, but this is just a big dumb list of 225 points. Okay? So I want to turn this into a data tree before I start plugging these in with these in order to make surfaces, okay? So let's take a look at that just for a second. I'm gonna go to the surface tool. In this case, I'm gonna use a surface from 3 or 4 points, right? Okay, and so I'm gonna plug in, let's say this, right? And then this, right? But right away, I think you can see the problem. This is a data tree, this is formatted as a data tree, and this is just formatted as a regular list, a flattened list. So I'm gonna go to sets, and I want to make sure that this is set as a data tree as well. Let me go ahead and say, first of all, there's a bunch of data tree tools here. I'm going to say graphed into a tree. Let's just see what it does, right? So here's our points. It says 225 locally defined values. This gives us a list of X, Y, and Z coordinates, defining each of those 225 points in the list. When I plug it into this widget, what do I get out? I get out a data tree, right? There's 0, semicolon 0, semicolon 0, all the way to 0, 0, 224, right? So 0 to 224, that's 225 items, 225 branches, and each one has an item inside. Now I can go ahead and do this, okay? So what I did is I basically connected up. Oh, come on. Right. It wants to create a surface from points, right? So I give it a set of points, and it'll just connect them up and create a surface inside, right? So what I did is I gave it this point, right, over here. I gave it these list of points with this widget, and I gave it these list of apex points that we just created with this widget, right? And we created those points over here as the endpoints, right? But then we wanted to actually format as a data tree before we plugged it into all these other things that were formatted as data trees. Okay, all right. So that's why I did that. And typically, if this starts to turn orange or this starts to really slow down and it gives you an exponentially larger amount of information than you expected, it's usually something not matching up right here, okay? That's what I'm gonna tell you right now, right? So that's the first sort of bit of problem shooting that I think is helpful to remember when you're working with data trees. Okay. All right, so it takes the first item from, or it takes the first branch and the first branch and the first branch of each data tree and makes a surface, and the second, makes a second surface, right? All the way across each of the 225 cells that we plugged in, okay? All right, let's do that again. I can make lots of pyramids. Man, just think what the Egyptians would have done with this tool. Grasshopper, good grief. Surface, freeform, 4-point surface. All right, now I'll start with the second vertex and the third vertex. And I'll plug in this apex point. Yeah, there we have the other, another 1/4 of a face of a pyramid, right? This is starting to look like a cheese grater. You don't want to rake your face across that, would you? All right, now, what's interesting, again, if I think about this, right? I'm gonna go ahead and pull this multi-number slider over here as well. All right, so we have a height that we can begin to play with. But we also have how open or closed, right? How much aperture we have, right, as a shading device by simply adjusting this, right? We can close this all the way up. It becomes opaque. Or we can begin to, you know, make things more open, okay? And we'll talk about next week is the fact that we can give different values for this across the surface, right? Based off of how much sunlight, direct sunlight's actually hitting each part of the surface. And so if it's about shading the most direct parts of the sun, right? The parts that actually receive the sun will have much more closed up or deeper shading devices, depending on how yours works, right? As opposed to some of the places that are already self-shaded or just don't receive a lot of light, or on the other side of the, like on the north side of the surface or something like that, that don't receive a lot of direct light, they can actually be relatively open, right? Okay, so we'll measure solar radiation hitting the surface, and we'll use those that information to actually inform these parameters like height and aperture. Cool, huh? I can tell you guys are excited. Anyway, all right. Now, again, you guys are going to have something much more interesting than this, because all I did was make a two-sided pyramid, right? I mean, that's pretty lame, admittedly. Okay, but hopefully you guys are going to do something more interesting than this. All right. Now, let's go over some of that lunchbox tool stuff that you looked at in the YouTube video. And let me explain where I'm coming from with that. First of all, what I'm going to do is I'm going to acknowledge that if you look at each of these cells, each of these triangles share at least one edge, right? And so if we think about, instead of having two discrete pieces that I have to glue together for each cell, rather, if I just had one sort of cutout piece with just a little score line that I can fold, right? That actually cuts down the number of joints significantly and the amount of glue I need to use, the amount of time I have to hold my pieces of chipboard together trying to get things together, right? And so what I'm going to do is I'm going to go ahead and try to join each of these together so that I get a sort of a poly surface on each cell for what I have there. Okay, I'm going to double click on the canvas and type in join, brep join, right? Brep is just a fancy way of saying poly surface. Okay, so brep join any number of breps together. Okay. This is already as a data tree, so I'm going to go ahead and leave it there. just going to go ahead and plug that in. We'll hold down Shift and plug this one in. All right. So we plugged in a list of 225 items and another list of 225 items, realizing that the first item from this list should be able to be joined with the first item from this list and become just a one poly surface. Yeah, I still have 225 now B-reps or poly surfaces. Good, good, good. All right, that's always pleasant when it works the way we expected. Excellent. Now, I gave a link to the Lunchbox tools. Again, if you're using the Mac version of this, of Rhino and Grasshopper, I'm not sure if Lunchbox tools will be even installed for you. If that's the case, just shoot me an email, and I can, you can give me the parameters you want, and I can just quickly unroll these things out for you, and you can go from there. It's not that big of a deal. I'll work with you on that. Or if you have access to a Windows machine, even just temporarily, you can install the trial version of Rhino and work off of it. But let's see, utilities, unroll brep. Okay, so once you install Lunchbox tools, you get a tab up here called Lunchbox, and you get another set of tools here. And under utilities, there's unroll brep. Right. So if I go ahead and plug that in, I say join unroll brep pieces. I'm going to go ahead and say true. I right-clicked on the join option and set the Boolean value from false, set it to true. Okay. I think what you'll find is that somewhere over here on the XY plane where z equals 0, basically the world coordinate 0, 0, 0 point. Okay. It's taken each of these and unrolled them and then placed them right here at the 0, 0, 0 point. Okay. So part of that definition that I give you is just simply making a point grid. Let me just get my annotate tools here. It's just making a point grid, right? I'll just try to make a grid of points here really quickly with the stupid annotate tool. Okay, and then simply taking each of these and moving it from the 0, 0, 0 point to each one of these in series, right? So suddenly then the second one would move from this point to this target point, right? And laying them out in a grid nice and neat instead of having them as overlap with like a serious cluster that we have here, right? Okay. And then the last thing I'm doing in parallel with that in that file is I'm generating a set of labels. So I generate a list of numbers, right? Like from 0 to 225 or 224 or whatever it is, right? And then another list of numbers from 0 to 224, right? And I combine them so that this one will be labeled 0 and 0, and this one will be labeled 0 and 1, and this one will be labeled 0 and 2, and this one will be labeled 1 and 0, and this one will be labeled 1 and 1, right? All the way to 240, 24, or whatever it is, right? Okay, so that's where we're going with this. I'm just gonna go ahead and clear that out. Okay. It's a lot to remember. Thankfully, Grasshopper does all this stuff for us once we set it up once in this graph for us. Okay, so first things first, let's make a grid of points. I'm gonna go ahead and go to vector, and we know there's a number of different ways we can make points with X, Y, and Z coordinates, but this one seems nice. Let's do a rectangular grid of points. Now, we're gonna have a base plane for the grid, XY plane by default. That works well. The size of the grid cells in each direction, in the X direction, the Y direction, and the number of grid cells in the X and the Y direction. All right. I'm gonna bring this over here to our original parameters. The number of these is gonna correspond to the numbers here, right? So I'm gonna go ahead and plug those in, because if we change the amount of divisions that we have for our original surface, it's gonna change the number of cells that we have, it's gonna change the number of unrolled components that we have, it's gonna change the number of grid cells that we need, right? So we'll go ahead and put that in right now. All right, and let's see, size of the grid cells in the X and the Y direction. That's just gonna be a simple variable based on how the size of these components, and just trying to lay them out in a grid where they don't overlap so we can see them and then arrange them later on for laser cutting. All right, so in this case, maybe I'll use a minimum of 0, but a max of like 30. I don't know, I'm just gonna ad lib here. It's probably way too large, but That'll give us lots of flexibility for sure. We'll go ahead and copy that and paste another one for the y, because the x and the y might be different. So you can always change those independently now, which I think could be kind of helpful. Okay. Now we had 15 points or 15 cells, number of grid cells. So 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points. We only have 15 by 15 components, right? So when we divide something 15 times and we look at all those division points, we actually have an extra division point. And so what I'm going to do is I'm going to write a little expression in here that tells Grasshopper that whatever I plug in here, subtract 1 from it and then use that. Okay, so I'm going to go ahead and right-click there and go to the expression editor and say whatever I plug in for x, subtract 1 from it and commit the changes. I'm going to do the same thing here. I right-click, expression, x minus 1, whatever's plugged in for x, I'm going to subtract 1 from it and then use that. Commit changes. Now I should have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15 points, right? Because I'm taking 15, subtracting 1 from it, making 14 divisions, which gives us 15 points, right? I know, it's weird. But intuitively, it does make sense if you just look, at each chunk and say, well, what are we doing here? All right. Of course, I can change the size of these in the x and the y direction. All right, but I have a list of points. Now I'm going to take each of these and then move them from the 0, 0 point over to this point. All right. So let's do a move command. Transform, array, no, Euclidean, move. All right, here we go. Move, translate along a vector. All right. So let's see here. Let me just double check the move stuff. Move away from, move to plane. What is this one? Target plane, AB. Nah. All right, we'll use this one. Okay. So instead of using a target point, like a sort of reference point and a target point, like you would do when you move something in Rhino, right? Let's say I want to move something in Rhino. I'll just draw a line real quick, right? I want to move it. It says select the object to move, right? And then it says select the point to move from and select the point to move to, right? Okay. So what we want to do is we want to say use this 0, 0 point as the point to move from, and then use one of these points in the grid to the point to move to, okay? All right. Now, in order to do that, let's see what we get out from here. So we get, oh, interesting. We get a set of points. And we have a data tree 0 to 14, so 15 branches, and each one is 15 points, okay? When we made this point grid, what's interesting about it is that it said, okay, well, you have 15 rows, and inside of that, each one you have 15 points, right? Nice. That's kind of a cool way of ordering them. Here we have just 225 unrolled surfaces, unrolled poly surfaces. But they're all plugged into just a 225 branched data tree. Now what I'm going to do here is I'm just going to flatten both of these into lists so that I can plug them in to this. Now the interesting thing is, again, I just want to sort of have one translation vector and one poly surface here, so that way they just move, one to one. The first one moves the first translation vector distance. The second item moves the second translation vector distance. Now I have to actually convert these points into translation vectors, which is not a trivial thing. But let's look at the data tree problem first, right? Just as we could take a flattened list and graft it into a data tree, we can take a data tree and flatten it back out into a list. Flatten a data tree by removing all branching information. So here we go. We're going to take this data tree. Now we flatten it out into a list of just a general list of 225 items. I'm just going to copy and paste that. I'm going to do the same thing for these points, right? Now, out of here, we just have a list of points in the same order, just kind of nice. Okay. Let's see. Now we need a translation vector. So essentially what we need to do is we need to, and let me just draw this with the annotate tools. It's a little helpful. Right now they're all sort of situated on the 0, 0 point, right? Okay, and so I need to find the vector between the 0, 0 point and the zeros in this point in the grid, and this 0, 0, 0 point and this point in the grid, and the 0, 0, 0 point on this point of the grid, right? So in other words, I'm going to draw a line between the 0, 0, 0 point and all of the points along this grid in order to generate a set of vectors to show where each one of these things moves to, okay? All right. It's an easy thing to do, but it's really important to understand why we're doing it, hopefully. All right, so I'm just going to make that 0, 0, 0 point. The easiest way to do that is to say XY plane. We'll plug that in. We'll plug in all these points. All right, now we have a line drawn from the 0, 0, 0 XY origin all the way to each of these points. I'm going to use those as translation vectors for each of these. All right. Yeah, that worked out well. Now, we have some changes to make to the spacing here, don't we? Seems like an unusual amount of spacing. And I'm going to go ahead and turn these lines off, like just turn the preview off so we don't see them, because they're really, after a while, it's like, what are we looking at? Let me see here. Which way's up? Adventures in tumbling in Rhino. Here we go. Okay. Lost my orientation here. Hopefully you don't experience vertigo easily, because yeesh, I'm just like vomit vision here, like moving around the Rhino today. Sorry about that. I'm just going to turn off the previews for all of these, right? And so you can see, right? Each one has been serially moved to a point in the grid, which is nice, right? Instead of overlapping now. Now go ahead and move these things closer and closer together to try to avoid some of the space waste here. Yeah. Ooh, we might actually be touching there. There we are. Ever so slightly. There we are. Right. So each one's different. And again, each one changes, right? Because they're flattened out versions of the three-dimensional things, and the three-dimensional shades are controlled by their geometry, by these, right? So as soon as I change this, these change as well. Yeah. And of course, the height, right? So as I start to adjust this, right, over here, I can begin to see the fabrication implications over here. How many sheets of information I'm going to need, excuse me, and so on and so forth, right? But the fabrication information over here for laser cutting updates accordingly, which is really handy. Instead of having to unroll and flatten all of those things again and again and again manually. I'm going to go ahead and save this at this point. It's always important to do. I'll call this, I'll just save it to my desktop here. I'll say unrolled, come on, unrolled shading components, because I'll use this example for next week as well. When we start measuring solar radiation, that'll be really important. Okay, and let's see here. So we have these. These are surfaces. They're polysurfaces, actually. And laser cutter actually just wants vectors, right? They just want like the outlines to cut through things, or exactly the paths to run the laser across, right? At a certain speed and a certain power to either cut through or score or whatever, right? So, all right, so let's generate some curves from these surfaces. This is where I have to think about, where does this actually occur? Curve to polyline, utilities, line, geodesic. I have to think about this for just a second. Can never tell if it's surfaces, edges from, oh, okay, edges from a surface. Let's see, edges from faces. It's like all B-rep edges that delineate certain faces. This might be it. Let's try that. So here we have found edges. Here we have edge indices. No, it's not quite what I want. Let's see here. It shows this in the example I gave you guys, but I'm just trying to remember here. Edges from length, edges from... What's nice is that the tool I identified is that it gives you both all of the sort of exterior edges as curves, and then also gives you interior edges as curves. And they break it down into individual outputs so that you can bake each one in a different layer if you need to, right? For things that are going to be scored versus things that are going to be through cuts for the overall shape. But I have to think about this for just a moment to remember. Yikes. This is embarrassing. Maybe it's over here. VREP edges. Check the edge curves of a VREP. Let's try that. Yeah, there we go. The naked edges versus the interior edges. Yeah. Okay. We don't have to worry, hopefully, about non-manifold edge curves. All right. So I'll plug each of these in. Now I'll get the outside edges. Each one should have 4. We get the interior edges. Each one should have 1, right? And so what we're talking about, this is a term that's used for meshes as well. But when we talk about naked edges, let me just bring that up, annotate tools. We're talking about the ones that are along the exterior, right? So edge curves, right? True edge curves where there's air beyond one of the edges, right? The interior curves, and there should be 1 for each of these, is there, right? So if we just separate those so that we just see the edges, the naked curves versus the interior ones, let's see, there we are. We'll turn off the preview here. We'll turn off this preview, right? We'll turn off the preview of this grid. It's the lines drawing through each cell is kind of annoying. I don't know who's texting me, but shut up, phone. All right. Then we get the exterior, right? That we can export on the red layer. Then we get the interior one for the scoring that we can then export onto the, or bake into the blue layer, right? For your laser cutter template. All right, so that's where that's coming from. The video that I showed you guys in YouTube that you were supposed to watch for today when it comes to taking these 3-dimensional components, modeling them, but also laying them out for laser cutting, right? Now, each one of these is different. And so you want to make sure that you know exactly where each one goes, right? Okay, that's really important too. So we need to maybe generate labels for these, right? And my YouTube video shows how to do that as well. But I do want to be very, 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 very clear here, right? This all starts with the sketches and your ideas for how to populate each of these cells, right? With a shading component made up of quad or triangular surfaces, okay? And so, you know, my recipe was this, right? You have a cell, find the vertices, right? Locate a U and a V, and find a point along the surface. Just turn the sound off my phone, that's annoying. Okay. With a normal direction, right? Now that I have these points, it was time to just connect the dots in particular ways in order to create some triangular surfaces, right? Okay. But this is bringing up a lot of the stuff that you guys used in Project 1, which is working with points and lines and curves. Because what I think what you're finding is that now that we've broken the surface up into little pieces, right? Inside of each piece, we can begin to identify locations as points. We begin to draw lines and scaffolds that allow us to then, you know, use to create more surface geometries. Okay, so we're going back and forth between those things. And that's typically how these would work. It's almost the exact same process you would use if you were trying to draw this manually by hand, trying to find a midpoint and a midpoint here, you know, finding this one, this point here to find that middle thing, and then projecting up with the normal, and then, you know, it's all the construction geometry, you know, that we're generating in the steps in between here that I sort of turn off. I turn off the preview for them, right, as we go. But really, that's the that's, I think, one of the great things about some of the analog work that you guys have done in second year, is that it gets you to think about how these things are constructed geometrically. And you have to do it over and over again with your pencil manually. Here, suddenly we can speed that up, but you still need that understanding, right, about what's actually happening geometrically. All right, let me go ahead and clear that out, close that. Now I can start to move things around here, okay? And again, we could, you know, close these up, right? Suddenly those are providing a lot more shade, right? We could open them up significantly so that they're hardly anything, right? And in fact, we could even adjust their height downwards, right? It seems to me that this height, the minimum maximum, could go down quite a bit to like -2 and +2 or something. There we go. Now I can be more granular in moving things. There we are. Okay. And so that next step next week is about, all right, what really informs these variables based off of, let's say, some sort of criteria, design criteria that you're using. Right? So we'll be using things like solar radiation. Okay. Imagining this is a shelter that can provide shade from the sun at a certain type of the day, at a certain time of the year. Right, so I'll be setting that up over the weekend for you guys so that we can touch the base on that on Monday. But what I want to make clear is that for today, you should have had at least bare minimum a sketch, you know, similar to the one I just drew over here in red, right? Sort of looking at each cell, looking at a cell and sort of trying to devise and sketch out how you would make a shading component that could be instantiated across each cell. And your assignment between now and Monday is to actually try to pull that off in Grasshopper, okay? Based off of, you know, some of these examples that you've seen here, you can find lots of different points and locations along these surfaces, along each of these cells, including the outside vertices, right, and the outside edges. And so from there, it's a matter of how do you connect the dots in order to create surface that can, you know, shading componentry. Okay. Is everybody signed up for laser cutter time? Is there any laser cutter time left at this point? I heard from someone that there might be a shortage of spots now or something. Let me just stop sharing my screen for a moment. So again, I mean, he blocked out all the time he could give us between Monday and whenever, next Monday. So if the slots are filled, you either missed out on probably, my guess is that Monday slots were not filled up. Now suddenly we have a shortage of slots. If that's the case, what you need to do is just really politely contact Kyle and say, I missed my timing. Vermilion decided he can give me a day or two extra to try to finish this thing. Is there any available time, or how do I sign up for an available 15 to 30 minute slot, 20 minute slot, or whatever it is, next week in the general population of slots, okay? But you're gonna have to sort of be polite and beg for mercy and forgiveness from him, because I sort of called in a favor to get him to just let us use it over this whole week ourselves. All right, so if that's the case, you have to reach out for some redo. Oh, okay. Well, what happened to the first one? Because look, I mean, that's why, you know, in a week or two, week and a half from now, you're going to be doing a second version.
Yeah, I did mine and I tried to put it together, and I think the offset was too long, so my ribs were really thick, and it was really hard to try to put them together, and quite a lot of them just ripped.
Yeah.
So I'm gonna have to change my offset.
Yeah, you might have to put all your, I mean, each piece will fit on inside the laser bed, but you might need more than one sheet of material.
Yeah, I did. I had 3.
Yeah. I'm responding to Ali.
Oh, okay.
But,
yes, I'm gonna have to rework.
So I also have a question. I did on thickness of 0.5. And
0.5 or
might be
0.05? Because that's like a magnitude
0.05.
of, yeah, okay, as I say, that's,
Yeah.
because half an inch is like, you know, okay,
Yeah, 0.05, sorry.
sure.
And like he said that his pieces were thicker. Mine is a little bit thinner because I did with your script with 0.250.
Yeah.
So it's not too small.
I don't know. You'll have to do it. Did you laser cut it and try to put it
Okay.
together?
I already did it. I did laser cut yesterday.
Yeah, have you started putting it together?
No.
How's it working? Yeah, that, I mean, that's the whole point. You're gonna narrow those things down. You're
Okay.
talking, everything you guys are talking about. So first of all, you guys are right on track. Okay.
Okay.
Everything you're talking about are parameters that can be adjusted as variables, right? Based off of ease of constructability and practicality of fitting things onto sheets, and C, aesthetics and proportions and beauty, right? So, you know, again, it's all about, you know, now you can start to adjust those things, right? Whether you're rerunning the script with some different numbers or you're adjusting number sliders in Grasshopper, one way or the other, right? Now you're going to feed it through that feedback loop. You're going to fail a couple of times, and that'll help you dial in those tolerances and those variables, right? The second time around, you'll actually get a lot better. It'll be stunning how much better the second version is from the first. I say that from experience.
So we'll have another week of scheduling for the second trial,
Yes.
correct?
Correct.
Okay, I just want to make sure. Okay, thank you.
Yeah. Awesome.
Hey Josh, I just have a question really quick. So
Sure.
I know in the demo, when you use the Rhino script, you put an offset of a 1/4 inch, right? So I was wondering if that's like what you recommend and that you know works the best, or do you think we should try?
No, I don't know. It really depends on a lot of things. I know where you're going here, Julian. So let me just share my screen and sketch something really quickly. Right. So so when it comes to these ribs, right? You know, there's this depth, right, or height, or whatever they call it, right? I was ad-libbing. You know, you guys know that better. And you know, to me, this is probably directly relations to the thickness of the material that you're using, right? And also the spacing of the notches. So, for instance, I would think that the more dense of ribs you have, maybe the less deep they get. Whereas if you
Okay.
only had like 1, 2, you know, let's say over the course of the surface, you only have like 5 ribs. That's way too few, right? But
Yeah.
for the sake of saying, you know, maybe then they could get deeper, right? Because, you know, you're spanning across, you know, more, right? So I think there's definitely a relationship there, both from a structural relationship, a material relationship with the thickness and trying to bend things and persuade them into place, right? And then
Yeah.
also just a simple, like, you know, what looks right? What looks too dense or too thick, based off of spacing, right? So, you know, there's an aesthetic side to things as well as a performative side of things.
Okay. And then one last question too is,
Sure.
so I know when we ran the script, when it adds in that score line, the score line bleeds over the cut lines. And so I was wondering if that's, so it just does one
Oh,
continuous
you're talking about
line.
that green zigzag? It bleeds over,
Yeah,
huh?
yeah.
Oh, weird. You don't have to use that.
Well, yeah, because I remember you said you use, like, you can use it to make your
Sure.
pieces a little bit more,
Bendy,
you know, like, yeah, bendy, so that way it can flex a little bit. So I was just wondering, like, for the laser cutter, because like they bleed over the edges just a little bit. So I was wondering, should you, like, does it matter if you trim those off, or it doesn't?
Probably
you know, if you
not.
leave it one continuous line,
you
it just
wanna-
follows that.
You know, to me, the one continuous line would probably be best because it just speed up the process a little quicker. But
Okay.
yeah. So really quickly, I mean, another thing that you guys will probably notice as you start to put this together is that you're going to start with one rib, right? And it's going to have some notches, right? And you're going to have another rib somewhere over here, right, with notches in the other direction. And you just want to like put this first one into place, right? And the first one's super easy. And then what do? You put the second one, and you try to put the second one into place with its notch, right? And then you try to put the third one in place with its notch. And over time, right, maybe the first row is kind of easy, but then when you try to put the second one down into it, right, in this direction, these start to come out. So what I found is that you either have to sort of synchronize this so that you either put these in place and then zap them with glue, or if you just think it's temporary, right, I'll start these things, I'll get these things together. Here, let me just try to draw this really quickly. Right, let's say that's a rib. Right, and then this one also is a rib. Coming the other direction, right? Right, so this intersection where these ribs come together, right, with the notches, you're gonna have to zap those with glue at some point. What I found is that if I have like little zip ties, you know what zip ties are? You know, they have these little things here, and then you run these through, and then they lock into place, right? I found that it's actually really helpful to put a zip tie here around this to sort of hold it in place, right? Sort of diagonally through it. And so as you go, you sort of zip tying it all together. And then once you have it all together and you let it settle, right? And then you can start to zap it in place with glue, each joint. And then you can just simply snip away the zip ties afterwards. Okay. So there's various ways you can begin to think about this, but the hardest thing was trying to figure out how to keep these in place as you start to put more in, because as soon as you start to put things on this side, you know, this becomes almost a fulcrum, and so you push this way and then they pull out this way, right? And so keeping everything together and locked in, interlocked, as you're assembling is really important, right? It's almost like having scaffolding in place to sort of keep things from falling over or keep things square while you go, okay? So I found that zip ties were like the thing I like the best here as far as how to do that. You know, it's sort of going around, you can see it here going around, sort of, you know, to hold these things into place temporarily until you get the whole thing together. Then once you get the whole thing together, you can sort of torque and twist it till it looks straight. Start to zap each thing with some super glue or zap gap, and then once it's dry, and you can just sort of snip everything away. Because I did this back in my office a couple of times just to sort of, you know, prototype the assignment for you guys. So, but that was the biggest help that I found, right? I tried binder clips, I tried all kinds of things. Zip ties were the way to go. And if you ask anybody from last year's class, I think I want to say a lot of them went with that strategy after a while. They might have found some other ingenious ways of doing it. You just have to ask them, but if you know any of them. All right, so I started sharing my screen. Where's the chat? Almost lost it last night trying to get it all to work. Yeah, look, it's going to be a source of frustration this first time around, okay? And between, for Monday, hopefully, but Wednesday drop dead deadline, I'll go ahead and put an assignment up for you guys on what do you call it? Sorry, for Wednesday. I'll put up assignment on Canvas, which is to simply show me some photographs of A, the process that you were using to put these things together, and then B, the final results, okay? We'll talk about the final results on Wednesday for this first go around, the first prototype, right? Remember, this is the draft prototype. Then you'll have a final prototype due another couple of weeks, okay? At the end of October. So that's the plan. But you know, again, for over this weekend, you know, while you're putting these things together or getting these things finally laser cut, right? Work on the componentry in Grasshopper, okay? And again, to me, you know, it always starts here with a piece of paper and a pen, you know, just sort of jotting things down, trying to sketch things out. It really does help when it comes to sort of understanding what you're trying to accomplish and step by step how to do it, right? You can also think ahead and break it down into the steps, because it's really easy to get lost inside Grasshopper. I'll tell you that, right? You like lose track of what you're doing and you're like, wait, what was this? And you know, it's really easy to lose track of it. So sketching really does help, honestly. Having that sort of pseudocode, that diagram, or just writing out the steps in plain English and just trying to follow them and execute them really does help. Okay. And again, what I did today, you know, identifying and pulling out all those critical variables, right? I think that's another important part of this, because we're going to be looking at those carefully next week when it comes to adjusting these things and then making each cell slightly different based off of its relationship with light. Okay, so more about that next week, but we'll get there. Okay, but the idea is that you guys have these components ready to laser cut for your second time around, right? So cool. All right. With that, are there any more questions? I'm going to stop sharing my screen for the time being. Any more questions? I'll, of course, post this to YouTube and Canvas as soon as I can for today, because I think hopefully it's helpful. But again, you're juggling several balls in the air right now, right? Like, so you're prototyping the structure, laser cutting it, trying to assemble it, trying to learn what you can from the assembly process, and learning what you can from working with this material. You'll have a chance to sort of revise, right? And again, the revisions don't have to be all done from scratch. You'll just go back and rerun the Rhino script, or go back and adjust some of the variables in Grasshopper, and then just rebake, right? Or you know, reorder them on this 18 by 32 sheets or whatever it is. So, all right. Excuse me. Throat's dry. It must be like starting to become fall. I'm just getting a hint of allergies. It's annoying. Anyway, it's still like 80s and 90s though. It doesn't really feel like October yet. Maybe by Halloween. Yeah, I feel that too, right? So every once in a while I wake up with some sneezes. So apologize for my voice sounding even weirder than usual. But anything else before we split off for the day? I might have some individual questions. I understand that. I know I need to meet Cirillo. We need to talk. Maya, I just sent you an email, Maya Nair. So if you have any questions, let me know. But if not, then have a nice weekend. If you run into anything that is blocking you from moving forward, please be sure to send me an email. Okay. And good luck. Look, first time you put these grid cells together, Ansenor. Yeah, I know, right? You're ready to like throw it across the room like a frisbee and stomp on it a couple times. Maybe run it over with your car back and forth. You just hate it. The second time, I think you'll be much more pleasant. All right, I'm going to pause.